Okay, very good morning to all. Today's GATE lecture based on the two-port network. Now, this GATE lecture this GATE lecture arranged by AICT sponsor Prerna Center for SC and ST students for organize our college VPKBIT Baramati. Okay, now these classes are started from 27 July 2020. Okay, now this session based on the electrical circuit in which we have conclude or we have complete today's topic is two-port network. Okay, now we explain the concept of two-port network. It is very useful for the GATE exam to solving the problem based on the two-port network. Okay, the two-port network means it consists of two port. First port is input port and another port is output port. Then this type of port is called as two-port network. Okay, then two-port network classify into four types. First type is impedance parameter. Okay, it is also called as Z parameter. Then second one is admittance parameter. It is also called as Y parameter. Okay, now next is hybrid parameter. It is also called as H parameter. And last one is transmission line parameter is called as ABCD parameter. Okay, now then first I have explained the impedance parameter is called as Z parameter. Okay, now this is the circuit of the two-port network in which input voltage is V1 and output voltage is V2. Then current I1 is flowing from input side and current I2 flowing from output side. Okay, now in impedance parameter in which voltage is dependent on the current, that means it's input voltage, output voltage depends on the function of I1 and I2. That means V1 is depends on I1 and V2 is depends on I2. Now the voltage in the form of impedance parameter, that is V is equal to Z into I. Then I have rearranged equation for I is equal to getting equation number 2. Then V1 is equal to Z11 I1 plus Z12 I2. That means Z1 that is the impedance from Z11 and Z12 that is impedance from Z21. Then obtain the voltage V2 from output side, that is V2 is equal to Z21 into I1 plus Z22 into I2. That is equation number 4. Now in this equation we have to find out dependent variables and independent variables. In impedance parameter, voltage V1 and V2 is dependent variables and current I1 and I2 is called as independent variable. Now impedance parameter consists of two steps or two conditions. First condition is output port is open circuit and second condition is input port is open circuit. In open circuit the current become 0 and short circuit in which voltage becomes 0. Now first output port is open circuit, that means the this port is open circuit. Okay, now this port is open circuit. At that instant the current I2 becomes 0 due to open circuit condition. Okay, then I2 is equal to 0. Put in equation number 3, that is equation number 3 is V1 is equal to Z11 I1 plus Z12 I2. Okay, then now I2 is equal to 0. Put in equation 3. Then obtain the equation is V1 is equal to Z11 I1 is equal to obtain Z11 is equal to V1 by I1. Okay, then this I2 is equal to 0. Put in equation 4. Okay, then obtain the equation is V2 is equal to Z21 into I1, then Z21 is equal to VT upon, sorry, V2 upon I1. Now this is input port, that is 1 plus 1 minus 1. Okay, or output port is plus 2 and minus 2. Okay, then in this condition the input port is called as driving port input impedance, and output port is called as reverse port transfer impedance. Okay, now in output port is open circuit. Now obtain the voltage V1 and V2, because voltage is depends on the current. Okay, then now second condition is input port is open circuit, that is I1 is equal to 0, that is input port is open circuit. Now obtain the equation is I1 is equal to 0, put in equation number 3. Now equation number 3 becomes, then I1 becomes 0, then V1 is equal to Z12 into I2. Then rearrange equation for Z12 is equal to V1 upon I2. Also put I1 is equal to 0 in equation number 4. Now obtain the equation for voltage V2 is equal to Z22 into I2. Then Z22 is equal to V2 upon I2. Then we have obtained the equation for Z12 is equal to V1 upon I2. Then I1 becomes 0. Then Z22 is equal to V2 upon I2. I1 becomes 0. Now in this condition we have to obtain four impedance, that is Z11, Z12 and Z21, and last one is Z22. Okay, now we have to draw equivalent network for the impedance network. Then from we have to draw equivalent network with the help of this equation. Okay, then V1 is equal to Z11 into I1. Okay, that is series, that is Z11 I1 plus Z12 into I2, that is Z12 into I2. Okay, now rearrange equation for V2, that is V2 is equal to Z21 I1, Z22, and current flowing through is output side is I2, that is Z22 into I2. This is the equivalent network for the impedance parameter. Okay, now we have to solving the problem based on the Z parameter. Okay, now given network is shown in. Okay, now this is the given network. Okay, in which it consists of two currents, that is I1 and I2, and voltage V1 for input side and voltage V2 for output side. Now this is the basic equation of impedance parameter, that is V1 is equal to Z11 I1 plus Z12 into I2, that is we are getting equation number 1. Then also for voltage VT is equal to Z21 into I1 plus Z22 into I2, equation number 2. Now same procedure for you, we have to use the this procedure also same use for solving the problem. First one is I2 is equal to 0, that is output port is open circuit, that is at this condition the current becomes 0. At that instant the current flowing from 15 ohm resistance becomes 0. Then at that instant the value of resistance is 0. Just 2 minutes. Okay, now we have to solving the problem based on two port network. This is the given network. Okay, now in which the input side current is I1 flowing and output side current I2 is flowing. Okay, now first condition is output port is open circuit. Okay, now current is I2 is equal to 0. Okay, at this condition there is a no current flowing through 15 ohm resistance. Okay, then apply KVL for input side, that is apply KVL for input side. Okay, then minus 10 I1 minus 5 I1 plus V1 is minus 10 I1 minus 5 I1 plus V1 is equal to 0. Then minus 15 I1 plus V1 is equal to 0. Then 15 I1 is equal to V1. Then V1 upon I1 is equal to 15. That is the in Z11 is equal to V1 upon I1. That is we are getting the ratio of V1 upon I1. Okay. Then Z11 is equal to V1 upon I1. I2 is equal to 0 is equal to 15 ohm. That means the value of Z11 is equal to obtain 15 ohm. Now also we have to obtain the Z21. Okay. Now this is the equation for V2. V2 is equal to Z21 into I1 plus I2 is equal to 0. Now the first we have to put I2 is equal to 0. Okay. Now obtain equation V2 as it is. Then this term as it is. Z21 is equal to V2 upon I1. Okay. Now apply KVL for this side. Okay. Already this resistance already 0. That is because there is no current flowing through I2. Then only present is 5 ohm at that output port. That the value of V2 is Z21 is equal to 5 ohm because the current becomes 0. That means the 15 ohm resistance as output side current becomes 0. Then the value of resistance becomes 0. Then obtain the Z21 is equal to 5 ohm. Okay. Now input port is open circuit. That is I1 is equal to 0. Okay. That is the I1 is 0. Then apply KVL for output side, that is minus 15 I2 minus 5 I2 plus V2 is equal to 0. Then minus 20 I2 is equal to minus V2. Then ratio of V2 upon I2 is equal to 20. Then Z22 is equal to V2 upon I2 with base I1 is equal to 0. That is input port is open circuit. That is I1 becomes 0 is equal to 20 ohm. Okay. Now also find out V1 is equal to Z11 I1 plus Z12 I2. Then put the value of I1 is equal to 0 because input port is open circuit. Then V1 is equal to Z12 into I2. Okay. Then Z12 is equal to V1 upon I2 with base I1 is equal to 0. This Z12 is equal to 5 ohm. Then in first condition Z21 is equal to 5 ohm because in this condition the 5 ohm resistance is common due to open circuit condition. Then we have to obtain Z22, that is V2 is equal to Z22 into I2 because I1 is equal to 0. Then Z22 is equal to V2 upon I2 with base I1 is equal to 0. Then the V2 upon I2 we have to already calculated. Z2 is equal to 20 ohm. Then Z parameter is given by, it is Z is equal to Z11, Z12, Z21 and Z22. The value of Z1 is 15 ohm. Then Z12 is 5 ohm. Then Z22 is 20 ohm and Z21 is 5 ohm. In this problem, we have to obtain the values of Z parameter with condition output port is open circuit and input port is open circuit. Now we have to explain the admittance parameter, that is Y parameter. This is the second classification of two-port network. Okay. Then in which the V1 and V2 are the independent variables and I1 and I2 is dependent variable. Okay. This is the formula of admittance parameter, that is I1 is equal to function v1 and v2, equation number 1. Then I2 is equal to function f2, v1 and v2, equation number 2. Now this equation in the form of parameter, that is I1 is equal to y11 v1 plus y12 v2. Then I2 is equal to y21 into v1 plus y22 into v2, equation number 3. Then I1 and I2 in the form of matrix form. Okay, I1 I2, it is as it is, and v1 and v2. Then this equation in the form of base form, that is I is equal to y into v. Okay, now in this condition, first condition is output port is becomes 0. First condition is output port is short circuited, that is the voltage v2 becomes 0, then I2 is present. Okay, now equation 3, that is this equation 3 is becomes, then put v2 is equal to 0. Now obtain the equation is I11 is equal to y11 into v1, then y11 is equal to I1 upon v1 with base v2 is equal to 0. Now another equation for I2 is equal to y21 into v1, then y21 is equal to I2 upon v1 with base v2 is equal to 0. Now this y11 is called as short circuit driving point input admittance, and y21 is called as short circuit forward transfer admittance. Okay, now second condition is input port is short circuited, that is v1 becomes 0. Now put v1 is equal to 0 in equation number 3, because this is the standard equation for y parameter. Then I1 is equal to 0 because v1 becomes 0, plus as it is y12 into v2, then y12 is equal to I1 upon v2 with base v1 is equal to 0. Now also put second equation for I2 is equal to v1 becomes 0, then this total term gets 0, then I2 is equal to 0 plus y22 into v2, then y22 is equal to I2 upon v2 with base v1 is equal to 0. Now we have to draw on the equivalent network for y parameter, that is y11, that is I1 is equal to y11 v1 plus y12 v2, then for I2 is equal to y21 into v1 plus y22 v2. Okay, this is the equivalent network for the admittance parameter. Okay, now we have to solve the problem based on the y parameter. Okay, this is the given network of the y parameter. Then okay, this is the given network. This is input voltage v1 and output voltage v2, then current flowing through is I1 and current flowing I2 from output side. Okay, now we have to modify this equation I1 as it is. Then we have considered two node points, that is point A and point B. Okay, now current I1, I2, then I3, then we have considered I4 and I5. Okay, now this is the modified network. Now apply KCL at point A. It is I1 is equal to, this is in 3 ohm branch current I4 is flowing, that is I1 is equal to I3 plus I4, that is equation number 1, that is I1 is equal to V1 minus V3 upon 4, then I3 is equal to V3 upon, that is I3 is shown in I3 is equal to V3 upon 6, because I is equal to V upon R, thus I4 it is V3 or V2 minus V3 upon 3. Okay, then solve this equation, then this term get left hand side, V1 minus V3 upon 4 minus V3 upon 6 minus then V3 minus V2 upon 3. Okay, then we are taking the LCM. 24 now is multiplied by 6, again 6 minus 4v3 minus 8v3 plus 8v2, because we are taking the LCM. Now this term total get shift to the right hand side, then value becomes 0. Now this equation as it is. Now we have to obtain the values of v1 and v2. Then 6v1 minus, then minus 6 minus 4 10 minus 18 v3 plus 8v2. Now we have to arrange the equation for v3, that is 18v3 is equal to 6v1 plus 8v2. Then v3 is equal to 6 upon 18 v1 plus 8 upon v2. Okay, then I1 is equal to v1 minus v3, because we have already taken I1 is equal to v1 minus v3 upon 4. Now in this equation the value of v3 is put. It is I1 is equal to v1 minus 6 upon 18 into v1 minus 8 upon 18 into v2. Now we have to solve this equation. Okay, that is v1 upon 4 minus 1 by 3, that is 1 by 3, and into 4 as it is, also this 4 as it is, minus 4 upon 9, then this 4 as it is into v2. Okay, now 4 get cancelled. Then we are taking the v1 as common, that is v1 is equal to 3 minus 1 upon, that is this is a into v1 into bracket 3 minus 1 upon 12 minus 1 upon 9 v2. Then obtain the I1 is equal to 2 upon 12 into v1 minus 1 by 9 v2. Then now obtain the current I1 is equal to 1 upon 6 v1 minus 1 upon 9 into v2. Okay, this is the current equation at point A. Now again apply KVL at point B, that is I2 is equal to minus 4 plus minus 4 I4 plus 5 I5. Okay, okay, that is apply KVL at point V2, that is I2 is equal to, because the current I4 flowing through 3 ohm resistance, that is opposite direction, then I2 is equal to minus I4 plus I5. Okay, so this I2 is equal to I5 minus I4. Then this is the I5 is equal to V2 upon 2. Then minus I4 is equal to, that is current I4 is, we have not shown, but in this 3 ohm resistance I4 is flowing, that is I4 is equal to V2 minus V3 upon 3, that is V3 minus V2 upon 3. Now solving this equation is equal to V2 upon 2 minus V3 upon 3 plus V2 upon 3. Then now taken the V2 from this two terms, that is 1 by 2 plus 1 by 3 into V2 minus V3 upon 3. Okay, now I2 is equal to 5 by 6 into V2 minus 1 by 3 into V3, that is equation number 5. Then equation 2, that is put in equation 5, that is equation number 2, that is okay, the value of V3 put in this equation. Okay, that is I2 is equal to 5 by 6 V2 minus 1 by 3, the value of V3 as it is put in this equation, that is 5 by 6 V2 minus 1 by 3 into bracket 6 upon 18 V1 plus 8 upon 18 V2. Okay, now next equation is 5 by 6 V2 minus 1 upon 3 into bracket is 6 upon 18, that is 1 by 3 into V1 plus 4 upon 9 V2. Then is equal to 5 upon 6 V2 minus 1 upon 9 V1 minus 1 by 3 into 4 upon 9 V2. Then I2 is equal to minus 1 upon 9 V1 plus, then solve this equation, 111 upon 162 into V2. Now equation number 4 and 6, that is equation number 4 we have solve is equation number 4 is I1 is equal to 1 upon 6 as it is minus 1 upon 9 V2. Then I2 equation number 5 as it is I2 is equal to minus 1 upon 9 V1 plus triple 1 upon 162 into V2. That is equation number 5. That is from equation 4 and 5 we are getting the admittance parameter is y11 is equal to 1 upon 6. That is y11 minus then y12 is equal to minus 1 upon 9. Then y21 is equal to minus 1 upon 9 and y22 is equal to triple 1 upon 162 into V2. These are the 4 admittance parameter of the above network. That is y is equal to 1 upon 6 minus 1 upon 9 minus 1 upon 9 into triple 1 upon 162. This is the admittance parameter. Okay. Then next parameter is hybrid parameter, that is H parameter. Okay. Now we have to explain the hybrid parameter. Okay. Then in which the hybrid parameter consists of two-port network, but in which the input port in which the voltage at input port and current at the output port. Okay. Now at that instant the output port consists of voltage at the output port and current at the input port. That means the voltage V1 is depends on the output voltage V2 and current I2 from output port, it depends on the current I1 and V2. That means V1 depends on the I1 and V2 and I2 depends on the I1 and V2. That means the current I1 and voltage V2. Current I1 and V2 are the independent variable and voltage V1 and V2 are the dependent variable. That means these values V1 and V2, V1 and I2 depends on the these terms. That is these are the independent variables and these are the dependent variable. Okay. Now above equation in the form of H parameter, that is V1 is equal to H11, that is hybrid parameter 11 into I1 plus H12 into V2, that is equation number 3. Then I2 is equal to H21 into I1 plus H22 into V2. That is this equation in the form of hybrid parameter. Now this equation number 3 we have to drawn in the form of matrix form, that is V1 V1 and I2 I2 as it is. Then H11 H12 H21 into H22 as it is. Okay, this is the matrix form equation and I1 and V2, that is equation number 4. Now in this condition or in this hybrid parameter, the case first V2 is equal to 0, then output port is short circuited, that is V2 becomes 0. Then V1 is equal to H11 into I1, that is then I2 is equal to H21 into I1 becomes the V2 becomes 0. Then H11 is equal to V1 upon I1 with base V2 is equal to 0. Then H21 is equal to I2 upon I1 with base 0. This is the output port short circuit condition. Then second condition is out input port is open circuit. Then in this condition the input port is open circuited, then at that instant the current becomes 0, that is I1 becomes 0. Then put I1 is equal to 0 then in equation number 3. Then V1 is equal to 0 plus h12 into v2, then v1 is equal to h12 into v2, then h12 is equal to v1 upon v2 with base I1 is equal to 0. Now again put I1 is equal to 0 in this equation, then I2 is equal to 0 plus h22 into v2, then I2 is equal to h22 into v2, then h22 is equal to I2 upon v2 with base I1 is equal to 0. Now the parameter h11, that is this parameter, is called as short circuit input impedance, and h21 is called as short circuit forward current gain. Then parameter h12 is called as open circuit reverse voltage gain, and h22 is called as open circuit output admittance. Okay, now we have to draw equivalent network for the hybrid parameter. Then v1 is equal to h11, this parameter h11 into I1 plus h12 into v2. Okay, this is the v1 equation. Now obtain the current I2 is equal to h21 into I1, then plus h22 into I2. That means this current I1 is flowing through this point. Okay, now at that instant the value of I2 is equal to h21 into I1 plus h22 into v2. This is the theoretical important part of the hybrid parameter which are using to solve to problem based on the hybrid parameter. Now we have taken problem on the hybrid parameter in next GATE lecture. Okay, now we have to request to all students to fill feedback form. That is, we have already shown the link for the feedback form. Then all students fill feedback form till 2 minutes. Okay, now I request to all students fill feedback form, because response is very important for my side. Okay, all students please fill this Google form. The link already I have shared in chat box. Okay, please all students fill this form. Okay.